Okay, so today we're going to start unit number 3. We're going to start unit number 3 with projectile motion. Unit 3 deals with motion that is multi-dimensional. So we're going to start with projectiles, and I want to make sure you understand a foundational idea dealing with projectiles. And that idea can best be seen by taking a look at this ball as it rolls off the end of my lab table. You could see when it was rolling across the lab table that it was covering a certain amount of ground in between frames of this picture. And you see that once it comes off the lab table, it still covers that exact same distance horizontally between every single frame of motion. So what this means is that the horizontal motion of that ball is not affected by the fact that it starts to fall vertically. Horizontal motion and vertical motion are two separate motions that are not influencing each other. So horizontally, it moves with a constant speed, and vertically, you can see it getting faster and faster, falling farther and farther. So vertically, it accelerates because of gravity. So again, horizontal motion does not affect vertical. Horizontal takes place at a constant speed. Vertical motion accelerates because of gravity. We could see this really well in this video I'd like to show you. So this is a little drone flying over a football field, and at some point I'm going to trigger the drone to release a ball. And you'll notice that as the ball falls, it continues to move horizontally at the same speed as the drone. So when it hit the ground, the drone was directly above it as it was hitting. The horizontal motion of the ball was not affected by the fact that it started to fall. We can see this frame by frame by the ball staying right underneath of the drone as it travels. Horizontal and vertical are separate motions. It continues with the same horizontal speed and it accelerates vertically. We can see this in this picture of this old bomber because you can see the bombs, especially the ones that were released first, are still right underneath the bomb bay. So even though that bomb was released back here, when the plane was back here, it continues to move forward with the plane. Horizontal motion and vertical motion are treated separately. They do not affect each other. We can see this with this little apparatus here, so let me explain it to you. It's a little spring-loaded gun, and we're going to fire one projectile horizontally. At the same moment, there's going to be a projectile in the back that will drop straight down. And the weird thing is, when we fire this, both balls hit the ground at the same time. Both balls stay the same height above the ground as they travel. I'm going to rewind it, and you can see them always at the same height above the ground. The horizontal motion does not affect the rate at which it falls. They are two separate motions. Realize, in order for this to work, the gun has to be held perfectly horizontally. If this little toy gun was angled upward, this toy dart would stay in the air longer than the one I drop. If I aimed it downward, this one I shoot would hit the ground way before the one that I drop. But when you fire horizontally, both will hit the ground at the same time, because horizontal and vertical motion can be treated separately. So now that we've talked a little bit about those big ideas, let's make sure you understand what a projectile is and what a projectile is not. So a projectile, by definition, is an object that is traveling through multi-dimensions where the only force acting on it is gravity. So it's traveling horizontally and vertically, multi-dimensions, and the only significant force is gravity. If we tried to use a little paper ball as a projectile, air resistance would totally mess up its flight. If we tried using a frisbee, aerodynamic lift would mess up its flight. If we were dealing with a rocket, it's powered. There's other forces besides gravity. So a projectile is where gravity is the only force. So when I throw something, as soon as it leaves my hand, it becomes a projectile. As soon as it touches the ground, it's not a projectile anymore. There's another force on it. Okay, so how do you deal with a projectile problem? Well, you break it up into two separate problems. Since the horizontal and the vertical are treated differently, separately, we just separate them into two problems, a horizontal problem and a vertical problem. The horizontal motion of the projectile gets treated like simple, constant velocity motion. We have delta x, we have v, we have t, and they would be related by the formula we learned at the very beginning of the year. Velocity equals displacement over time. On the vertical side, we have our 5 variables, so you have to use the 3 equations of motion that we've been using for all accelerated motion, okay? So this is how you're going to tackle a projectile problem. Break it up into 2 different parts. This is the vertical displacement, this is the horizontal displacement. Initial vertical speed, final vertical speed. Horizontally, there's only one speed because it doesn't gain or lose speed horizontally. Acceleration, that'll be negative 9.8 if you're on Earth. And time is important because time links the 2 sides together. While it's a projectile, it's going to have the same time moving vertically as it was horizontally, okay? So let's do a couple problems just to make sure you're clear on how this works. We'll have our little drone flying over the football field, and this time we will track the motion of the ball. So this is where we let go. That's the initial. This is where it lands. That's going to be the final. Realize the final happens the millisecond before it hits the ground. Once it hits the ground, it's not a projectile anymore. Okay? So we take a look at where this started. We look at where this ended. And we subtract those 2 locations to get our delta x. It turns out this is about 4.65. This is about 1.55. So this turns out to be about 3.1 meters. Vertically, we look at where the bottom of the ball starts. We look at where the bottom of the ball ends. It starts at 2.5. It ends at 0. So the difference is negative 2.5. Please make sure you make it negative because it ended up lower than where it started. It started high, it ended low, it lost 2.5 meters of vertical position. The initial vertical speed was 0 because we didn't chuck the thing down or throw it up, we just dropped it, okay? The planet is Earth, so we make it negative 9.8. At this point, you guys should be able to find the final speed. It should come out to a negative number because it's going to be moving downward. Note, it's not 0 because you're not looking at the speed after it hits, you're looking at the speed right before it hits. So that is not 0. Then you can find the time, plug it in here, and solve for the velocity. I would like to see that work done in your notebook, nice and neat. One more I'd like you to try. This time we have a soccer player throwing the ball in. When it leaves her hand, the ball's moving horizontally. She doesn't throw it on an angle. We'll deal with that later. And we'd like to figure out how long it's going to be in the air and how far it's going to travel down the field. So again, you make your chart. It's thrown horizontally at a speed of 5, so that's the horizontal speed. That does not change as the ball moves vertically also. She did not throw it up or down. She threw it perfectly horizontally, so the initial vertical speed is 0. The planet is Earth. And the change in height is from the ground up 1.7 meters. You make it negative because the ball is going to go down 1.7 meters during its flight. Find the speed at which the ball hits the ground, find the time, bring it over here, and find out how far the ball is actually going to travel before it hits the ground. Again, show me your work and work it out to completion in your notes. Okay, here's the actual throw, frame by frame. And you see the ball eventually landing on the ground. Boom. It's no longer a projectile as soon as it touches the ground. All right, then there's another force on it. Hopefully you guys understand the big ideas. Horizontal motion and vertical motion are separate. Horizontal motion happens at a constant speed. Vertical motion happens just like free fall. We'll be applying this to more complicated projectiles in the future, but for now, all our projectiles are going to be fired horizontally.